Hello and Assalamualaikum Doctor. My name is Muhammad Salfi and I'll be starting the introduction of our assignment 1 of statistics project, design of experiments. So first things first, let's get to know our team members. Our team members are Nick Syami Amza bin Nick Mazlan, 228528, me, Muhammad Salfi bin Idrus, 230179, and then Muhammad Juni Damia bin Jihad, 228751.
For introduction, caffeine is known for its stimulating effects that can temporarily improve alertness and energy levels. For students, this can be particularly helpful when dealing with early morning classes or last-minute cramming. The availability of caffeinated products on and around campus makes it easy for the students to develop a routine of consumption without fully considering the long-term effect. This study, titled Campus Caffeine, a study of student consumption patterns, aims to explore the daily caffeine habits of university students through a series of questions regarding average caffeine intake, preferred caffeinated products, reasons for consumption, and frequency of use. We hope to better understand how caffeine fits into the lives of students and what patterns emerge from its consumption.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nick Syami Amza bin Nick Mazlan, and now I will move on to the problem statement. The problem statement is, caffeine is widely consumed by university students to support their academic activities. This study seeks to explore these consumption patterns and determine whether the average daily caffeine intake of UPM students differ from the national average of 100 mg. Okay, we move on to the methodology. This study utilized a quantitative survey approach to examine the caffeine consumption patterns of students from the Faculty of Engineering at UPM. Data were collected through an online questionnaire, and the survey was launched at May 8, 2025 and distributed via social media platform to reach broad range of participants within the faculty. 91 students respond to the questionnaire, providing insight into their daily caffeine intake. The survey consists of 4 questions designed to gather quantitative information about the amount and frequency of caffeine consumption among respondents. Convenient sampling was employed due to the accessibility of participants within the faculty and the unknown total population size. For data analysis, a two-site t-test was conducted to evaluate whether the average daily caffeine consumption of UPM students differ significantly from a national average of 100 mg. The t-test was selected over a z-test because the total population size was unknown and the population standard deviation was not available. A significant level of 0.05 was used to determine the statistical difference between the sample mean and national benchmark.
So let's get into the result discussion. I'm in charge of the analysis representation for our project. So as we can see in the first pie chart, among 91 subjects, the majority, 60.4%, use less than 50 milligram of caffeine daily, making low caffeine the prevalent. Approximately 18.7% use 50 to 100 milligram, and 17.6% use 101 to 150 milligrams of caffeine a day, making them a substantial group with moderate use. Only 3.3% use over 150 milligram daily, making high caffeine use rare in the group of respondents. Moving on to the second chart. This chart is about which caffeinated product do the respondent consume regularly. So as shown in the bar chart, out of 91 respondents, coffee is the most commonly consumed caffeinated product with 65.9% of reporting regular use. And then tea follows second at 57.1%, while energy drinks are consumed by 49.5% of respondents. And then soft drinks are the least popular among the options, with 37.4% indicating regular consumption. This graph shows that coffee and tea are the preferred sources of caffeine, while energy drinks and soft drinks are less common. And then we move on to the third pie chart. From this figure, we know that 36.3% of respondents consume caffeine in order to feel awake, making them the majority of the chart. The second biggest factor for consuming caffeine would be a tie between to improve concentration and to increase physical energy, which would tie into each other with both at approximately 20%. The least popular reason would be to alleviate stress and consuming for social reasons, with both reasons at approximately 11%, meaning that they are in the minority. And then for our last pie chart, figure number 4, we asked the respondent how often do you consume caffeine. So as shown, out of the 91 respondents, more than half of them, 52.7%, would consume caffeine 1 to 3 times in a week. And then 4 to 6 times in a week, 26.4%. And respondents that do not consume caffeine at all, 18.7%, make up a substantial portion for the pie chart, signifying the lower and the upper boundary for the test. And then the least amount of response is towards 2 to 3 times per day, making up only 2.2% of the respondents. Shockingly, there was no response for more than 3 times a day, because who drinks coffee 3 times a day, right? More than 3 times a day, right? Alright.
Okay, now we will move to our hypothesis testing number 1. Okay, for the first testing, we use the caffeine intake of student in the UPM to compare it to the average caffeine intake of 100 milligram. Okay, as you can see here, we have 4 category, which is less than 50 milligram, 50 to 100 milligram, 101 and 150 milligram. For more than 150 milligram, we assign 175 milligram as an approximate midpoint. As you can see here, each category has their own midpoint, count and their own percentage. We also assume the more than 150 range is 150 to 200. Okay, now we will move to the calculation. Okay, at first we will find the mean by using the formula. Okay, then we find the mean, which is 56.87 milligram. Then we will calculate each square deviation time for each category. And for 25 milligram, we will get 55,896.5. For 75 milligram, we will get 5,588.1. And for the 125 milligram, we will get 74,267.2. And lastly, for 175 milligram, we will get 41,853.3. And we can use them to get both sample variance and standard deviation. For the variance, we will get 1,973.39. And as for the standard deviation, we will get 44.43 milligram. And by using the obtained value, which is the mean and what the standard deviation and variance as and also standard deviation, we can find the t statistic. We use the formula to find the t statistic, and we will get the negative 9.25. Okay, after that we will find the degree of freedom and critical value. The degree of freedom is 90, and for a two-sided test at A equal to 0.05, the critical t value is plus minus 1.987. Okay, since modulus t is 9.25, is much greater than 1.987, we reject the null hypothesis, which means the average daily caffeine consumption of UPM engineering student is statistically different from the national average of 100 milligram. Okay, that's all for the hypothesis testing number 1.
For hypothesis testing 2, We get the results from 91 responses. We know that 60.4% consumes less than 50 milligrams, 18.7% consume 50 to 100 milligrams, 17.6% consume 101 to 150 milligrams. So the remaining, which is 3.2%, consumes more than 150 grams. From those data, we can calculate the total caffeine of 5,175 milligrams, and the mean or average is 56.9 milligrams. So in the standard deviation table, we can conclude that the sum of fx minus mean squared is 777,575. So with the sample size n91, so the standard deviation is 44.4 milligrams. For the hypothesis, we will use the t-table, and we'll get the t-value is negative 9.24. Thus, we can calculate the p-value, which is 0. So since p-value is less than 0.1, therefore the null hypothesis is rejected.
As for the conclusion of our presentation, from the conducted survey and data analysis, it can be concluded that the average daily caffeine consumption of university students at UPM is different from the national average of 100 milligram. Through the hypothesis testing that we did, both hypothesis testing 1 and hypothesis testing 2, both concluded that the alternative hypothesis, HA, is accepted and the null hypothesis is rejected. This is held true since both the p-value in both testing is less than 0.1. From the project, we divided the tasks equally and performed said task gracefully, while fully supporting each other whenever a challenge arises. As the project progressed, I saw how each team member brought their idea, especially for the questionnaires. And it was impressive to see everyone doing their part and supporting one another, especially when another challenges come up. This project has shown us the value of collaboration and have given us a new appreciation for what can be achieved when people work together towards a common goal, which for us is making this project a success. Thank you so much. Thank you so much for listening, and have a nice day.